This lab is all about pulse width modulation using the internal hardware of the S12B board. What we have here is a power MOSFET. We'll be using that later on in the lab. You pick up the pulse width modulation in the PP header, which is under the target label here. Take a look at the lab handout for the exact wiring details. We'll be using the light bulb as well later on in the lab. Okay, well, as far as the scenarios of this lab are concerned, we have 4 different trials that I'd like you to do. Each of the trials is outlined in the lab handout, and each one has a different frequency or period that's associated with it, which requires you to change certain parameters in the reserved registers that are set up for the pulse width modulation. So I'm going to just show you one of the examples here, and you run through the same thing several times in your examples. We're going to be using pot 1 over here to vary the duty cycle. So you're going to have to still use an A to D conversion to read pot 1's 8-bit value and send that to the duty cycle part of the pulse width modulation. The reason I did that was so that you can vary the duty cycle and see it on the oscilloscope in real time. Alright, so let's go ahead and execute the code here. We're going to download it to the S12B board, and we're going to begin the process of running. So I'm going to hit the run command here. And as far as the board is concerned at this point, nothing's going to happen on the board. But if you look at the oscilloscope here, you'll see that it has a certain period that you're going to have to measure. So you're going to have to measure the frequency or the period of that. And it doesn't really matter what duty cycle, and I am varying pot 1 right now. And as you can see, by varying pot 1, I can go ahead and vary that duty cycle from 0 to 100%. So I'm close to 100% right now. Now I'm at 100%. Then coming down, here we have about 50% duty cycle, going down further, almost to 0, and then now to 0. So, and that's all by just varying pot 1 here. And so that 8-bit value is the 8-bit value that's being varied here on the oscilloscope's duty cycle. So the key thing is to measure that period and compare that to what you predicted. And don't continue to the next trial until you are verified that you get the period that you asked for. And that concludes really the first part of the lab. The second part of the lab is connecting the bulb to the power MOSFET. Take a look at the schematic for that. I'm going to go ahead and ground the MOSFET so it works now. And as you can see, as I vary the duty cycle by changing the pot's value, I vary the brightness. And so here at 100% duty cycle, of course, the bulb is full on. And as I go down to a lesser duty cycle, and you can see that here, the scope is following this as well, you can vary it all the way down to 0. So what that does is gives us an ability to vary the intensity or the power output to a light bulb without using any sort of analog output digital to analog converter like we did in a previous lab. This lab is purely digital. Now the temperature sensor part of this lab is not connected. Those 2 wires are just hanging here. We're not doing any sort of control. So the whole point of this lab again is to understand how to set up the duty cycle and the period of a PWM signal coming from our board in software, and then going ahead and setting up this little power circuitry using a power MOSFET and seeing the result of that.